Hello everyone, and in this video, we're going to be taking a look at a technique that can trivialize this GMO problem 3. So here's a problem. Suppose you have an equilateral triangle ABC, so ABC is equilateral, and if you have a point P on the circumcircle. Then you construct the lines AP, BP, and CP, and they intersect the opposite sides at points D, E, and F. And what we want to prove is that the area of DEF is equal to 2 times the area of ABC. So that's what we're set out to prove. So how can we get started on this problem? So here's where the big technique comes in. We're going to be introducing a new coordinate system that will assist us in solving the problem. And this coordinate system, you may be asking, what is it called? It's called barycentric coordinates. So I spelled it all on the screen. That's what the name of it is. So what are barycentric coordinates? Well, the basis of the idea is that if you have 3 coordinate axes, this is a z-axis, this is the x-axis, and this is a y-axis, and then if you have your triangle, suppose A, B, and C, the key idea is that you can put the vertices of the triangles on the axes such that A is on the z-axis, B is on the y-axis, and C is on the x-axis. We can try doing that. And if we appropriately scale down the axes, we end up getting a nice configuration for stuff. So let me go ahead and this should be X and this should be Z. So that means that we can label the points as A equals 1, 0, 0, B is equal to 0, 1, 0, and C is equal to 0, 0, 1. And this plane here, the plane ABC, to make sure that we don't have a point that's over here or over here, for instance, the barycentric coordinate of a point inside the triangle is defined as x, y, z, which is just x times the vector A plus y times the vector B plus z times the vector C, and we must have x plus y plus z is equal to 1. And we can just define the origin of where these vectors come from, like where the origin is, so to say. It could be anywhere because the location is still preserved. So now, given this definition, we can state our first important fact. So that if you have a triangle ABC, so ABC, and then I'll go ahead and label the points here. A is 1, 0, 0, B is 0, 1, 0, and C is 0, 0, 1. And then you have a point P inside, which is X, Y, Z. Then you have the BPC, and then APC and APB. A good way to remember what the barycentric coordinates are is that it is the area of BPC, the area of CPA, and then the area of APB. You might be asking, why am I using colons instead here? Well, it's just a neater notation, so to say, instead of just writing BPC over ABC, CPA over ABC, and APB over ABC in order to make it such that x plus y plus z equals 1. And this is called the homogenized version of the barycentric coordinates because the sum can be anything. We're just scaling it up. So if we have x, y, z, where x plus y plus z equals 1, it is equal to kx colon ky colon kz. So that's something. So, and here's a second important fact you'll need to know. I'm gonna state it without proof because the proof is kind of complicated for this video. So you have ABC, and then you have a point D, which is x1, y1, z1. And this is non-homogenized, which means that their sum is equal to 1. And this is E, which is x2, y2, z2. And then we have F, which is x3, y3, z3. Then the area of DEF over the area of ABC is equal to the determinant x1, y1, z1, x2, y2, z2, and x3, y3, z3. For those who don't know what a determinant is, I'm going to explain it right now. And for those who do, you can skip to the timestamps shown on screen. So, what is a determinant? So, the notation A, B, C, D, E, F, G, H, I, what that equals, we want to know what that equals. Before that, we needed to find the notation A, B, C, D, the determinant of a 2 by 2 matrix, which is AD minus BC. That will ease the memorization of the definition. And now the determinant here is equal to A times EFHI minus B times DFGI plus C times DEGH. So that's a good way to memorize it, and the determinant is defined over here. So that's what a determinant is, and this is the area formula that will come in handy for the JMO problem. And one last fact is needed. If you have a point P here that is x, y, z, then the line AP, it's given by the equation x or x, y, z, like the point, if there's a point, suppose Q on the line, then ends up being T, Y, Z, where I'm using colons. And when T equals X, we have the point P. When T goes to infinity, we have the point A. And when it's anything else, we have just the line here. This line. So these are, and there's actually another fact. The circumcircle is given by the equation negative a squared yz minus b squared zx minus c squared xy is equal to 0, where a is equal to bc, b is equal to ca, and c equals ab. So enough with the concept, the required concepts. Let's get to solving the problem. So we now have ABC equilateral and DEF, which is the intersection of AP, BP, CP with the opposite sides. We wish to show that the area of DEF is twice that of ABC. What motivates us to use barycentric coordinates? We have these intersections with opposite sides, in particular AP intersect BC, BP intersect AC, and CP intersect AB. So we're inspired to use barycentric coordinates. Plus, this circumcircle ends up being really nice because of our circumcircle equation. And finally, to interpret this area condition, we can end up using the barycentric area formula. So enough with the setup, let's get to work. So the circumcircle is given by the equation negative a squared yz minus b squared zx minus c squared xy is equal to 0, where a is 1, 0, 0, b is 0, 1, 0, and c is 0, 0, 1. And a squared, b squared, c squared, they're the squares of the sides of the triangle. But this is equilateral, so the sides are all equal, which means that they all vanish, and we get xy plus yz plus zx equals 0. So this is the equation that P must satisfy. So if P equals xyz, then we know that the point D is equal to something the line AP is given by TYZ, and whenever we have when t equals 0, that means that it lies on the side BC because there's no vector corresponding to A, or if you'd like to think of it this way, the area of BDC is equal to 0 because all the 3 points are collinear. So that means that the D is equal to 0, Y, Z. And this is homogenized, so we need to rehomogenize it if we want to use an area formula. So 0, Y over Y plus Z, and then Z over Y plus Z. And similarly, E is equal to X over X plus Z, 0, Z over X plus Z, and F is equal to X over X plus Y, Y over X plus Y, and 0. So now that we know the coordinates for D, E, and F, we can start evaluating the determinant. So the area of DEF is equal to the determinant of 0, Y over Y plus Z, and Z over Y plus Z, and then X over X plus Z, 0, Z over X plus Z, X over X plus Y, 0, and Y over, Y over X plus Y, and 0. And so let's go ahead and start evaluating it. By our formula that I stated, it must be equal to 0 times the determinant of 0, Z over X plus Z, Y over X plus Y, 0, minus Y over Y plus Z, times the determinant of X over X plus Z, Z over X plus Z, and then X over X plus Y, and 0, plus Z over Y plus Z, times the determinant of X over X plus Z, 0, X over X plus Y, and Y over X plus Y. This first determinant here vanishes because we have the 0 in front of it. The second determinant ends up evaluating to XYZ over X plus Y, Y plus Z, Z plus X. And then the last one ends up evaluating to XYZ over X plus Y, Y plus Z, Z plus X. So we end up getting 2XYZ over X plus Y, Y plus Z, and Z plus X. And this is a ratio, and this is over ABC. And if we want to get the actual ratio, I forgot to mention this, we needed to take the absolute value. So we take the absolute value, we want to show this is equal to 2. And thus we'd like to show that 2XYZ over X plus Y times Y plus Z times Z plus X is equal to 2. And is equal to plus or minus 2. If we cross out the 2 from both sides, we get this. So XYZ is equal to plus or minus X plus Y, Y plus Z, Z plus X. Let's actually show that the minus sign holds. So we want to show that it's minus this. If we end up expanding everything, we end up getting x squared y plus y squared x plus z squared x plus xz squared plus y squared z plus z squared y plus 3xyz is equal to 0. And for those who are experienced with factorization, you might immediately know this is x plus y plus z times xy plus yz plus zx, and this must equal 0. If you're not convinced that this expression here is equal to this expression here, you can just expand it out. And now we want to prove this. But remember from our circumcircle equation, that xy plus yz plus zx is equal to 0. So this entire thing is 0, and we're done. So this is one of many problems that end up getting trivialized by barycentric coordinates, as we saw here. And with the area formula and determinants, we were able to prove that DEF over ABC is equal to 2. And that solves the JMO problem 3, which is one of the hardest problems on the test. So thank you so much for watching. I hope you enjoyed.